All right, so this video hopefully will be a little bit shorter. And this one, we are going to be creating a footprint for the SOIC and 1.7 millimeter max height. Um, and this is the dimensions here that we will be using for it. And just to show you what I've got here, I've already created the pad stack. And I will be uploading this document. I found a really nice document talking about convention rules for naming pad stacks. And so this is a rounded rectangle, and so I'm doing R. It's 1.55 millimeters wide and 0.6 millimeters height with a rounded rectangle of 0.05 millimeter radius. And so you can see the name up here. And so we've got all of that done. And so I'm going to move on to the SOIC chip, but let's go back to some naming conventions for the SOIC. And so let's bring the document for naming. And so an SOIC is a small outline integrated circuit, and it says 50 millimeter pitch, or 50 mil pitch here, not millimeter, 50 mil pitch, which corresponds to 1.27 millimeters. Now that's a standard pitch for an SOIC. If for some reason you have an SOIC that's different, you would just change this number for the pitch. But let's just go ahead and look at the data sheet to verify that if I look at my pitch here, where's my pitch? Right here. And it's 50 mils or 1.27 millimeters. So it's the standard one. So our name, let's go back to our naming convention file, would be SOIC 127P, and then lead span nominal by height dash pin quantity. Okay, well, let me get back here. So it says lead span nominal. The lead span here gives me a typical value of 0.228 to 0.22244 millimeters. I'm sorry, not millimeters, inches. And then the one in bracket is the millimeter. And if we want to use the nominal value, which we'll go ahead and do in this case, it'd be 5.8 plus 6.19. So that's essentially 12. So we could do, let's just go ahead and do 6 so that we don't have 5.995. So 6 millimeter. So we'd have 6 X, and then let's see here, where's my SOIC thing again? Okay, right here. And then by height dash pin quantity. And so if we look here trying to find the height again of this, might have to look in several locations to find the height of this package. And actually it's not written here anywhere, but it's written at this top here, 1.75 max height. So it would be X175 and then dash 8 pins. And then as far as the suffix that we could add here, now with the landing pads, the way that we're generated them, this would, we don't really need to put an M, N, or L after. I mean, we can, but in this case, we wouldn't be able to make the pad stacks any smaller because we used what the data sheet told me to do. I can't make those any smaller. And if I make the chip smaller, then, well, that's a different package. So it's not like I can make the chip smaller. So this footprint is basically going to just be for the other one. You might say, well, we did it differently for the other one. Well, that's because we had pad stacks that actually had drill holes with copper pads surrounding them, and we could have a different size for those copper pads based off of whether we did level A, B, or C. And so we have to be able to indicate that in the footprint name when you have those through holes. But since this isn't a through hole, there's not really an A, B, C level because it's the chip. You know, there's nothing we can do as far as making these landing pads bigger or smaller. Okay, so we don't need to put that any kind of suffix on there. So then let's go ahead and do our wizard here. So new. Well, actually, let me double check and do user preferences, because this is my computer on my and at work, and I purposely deleted the pad path because, again, what should we always check? Make sure that the pad path has where your pad stacks are being stored. So mine are being stored on OneDrive, Cadence, pad stacks. All right, so I add that there, apply, click OK, and I'm going to do File, New. I'm not going to save this. And then where am I saving it? I'm saving it in my footprints, OneDrive Cadence footprint. So I'm already in there, and you can see I have other footprints. These actually aren't using the proper naming conventions as a side note, but there's other footprints already in there. And so the naming convention says this should be SOIC 127P, and then it was 6 by 1.75, and it was 6.0. So I really should I should do 600 because that's 6 millimeters, so it's 6.00. So I really should do 600. Otherwise, 6 might be should be interpreted as 0.06. So it's important to put the 600 that I almost left off, and then dash 8 pins. And so we'll click OK. And I forgot to actually use the wizard. So let's do that. Wizard, I forgot to select the wizard. And I went ahead and saved it just so I could not have to type the name back in. It says overwrite, yes, okay. So now I need to select SOIC. Next, load my template. Next, we're in millimeters. Remember, we do everything in millimeters. This is a chip, so we'll still do it with a U. Hit next. Okay, make sure to change it to the correct number of pins, 8. Lead pitch is 1.27, has that in there by default. Terminal row spacing E1. Now notice it's halfway between here. So it's at 5.715. If I go back to the data sheet, this is something that you have to actually do a little bit of thinking. So it's looking for in the middle of this pin here is what it's looking for. That's the dimension it's looking for. And so that's not easily given here. We can see the width of this is, 5.8 to 6.19. And then the width of the part here, the package itself, not including the pins, is 3.81 to 3.98. So let's look at what was the default that was given, 5.715. So wait, well that's smaller than this 5.8. So 5.715 is the default that's in there, and that is going to give us roughly what the nominal value is, because if I look here, this distance here, 1.04 is typical, and if I do that and divide by 2, so I'm going to do calculator here, If I do 1.04 divided by 2, that essentially gets me halfway on this pin. And then if I add that to the, what am I looking at here? This 3.98, but then add another 0.52 because you got one on either side, you get like roughly 5. And so it's saying 5.715 here for the terminal row spacing. And it's saying the package width is 4.415, which is too big as well. So let's go through that computation again. So I'm looking for a dimension that's halfway here between these two. So I'm drawing a line here vertically. And I'm looking for the dimension between those. Let me download this and see if I can get this to actually, and then open it with my system viewer. Okay, so I just want to make sure that everyone's clear here. So let me go ahead and see what we can do here. Now close. I'm going to just go ahead and do this edit PDF here. See if I can I was seeing if I could just draw a line. Well, here, let me see if I can do it this way. Well, that's not highlighting all the text. That's not what I want to do. Now, I can't figure out how to get it to do this real quickly, so I'm not going to waste our time anymore. But again, I'm going to draw my hand. It's from the middle of this pin, this dimension, all the way to the middle of the other pin. So like over there, that could be where we start, to roughly, I don't want to be moving, to roughly like right here. So to do that, I'm, in this case, just using the maximum value here, 3.98 of this package. And then I'm looking at this as 1.04. Now what I did, and actually we could just use the 1.04, because what I said is I divided that in 2, because that gets me halfway here. But then I got a half here and a half here, which is really just a whole. So the dimensions 3.98 plus 1.04. So let's go ahead and be technical and say it's 5.02. So I'm going to go back to my PCB editor. This is 5.02. Then the package width, if I go here, we can see that the package width, well, let's first off make sure I'm doing the right thing. Package width E, that is literally the width of the package. That is 3.98 is the max, which is what we're using. And then the height here, 5 is the max. And then I'm going to click next. And then I'm going to select my pin. Now, my pin name started with an R. And here it is, R155, 1.55 underscore 6, rounded 5. Now, with these pins, we typically don't have necessarily a different pin for pin 1. So I'm just going to do next, next, finish. And say, hey, do you want to overwrite this? I was like, yeah, I want to overwrite it. And then we see finish. And then you can see here, we've got our nice little landing pads here. And we've got the package width here. And you can see that there's a tiny bit of overlap of the copper underneath the pin there. But that is a fairly typical thing for us here. And then you can see the different layers, the solder mask layer and the solder paste layer. And then we have our pin, or not our pin, our footprint. And just like the other one, if I look at my footprints, as I said, I got a lot of here that are not named correctly. But if I see here, there's this DRA and this PSM. And they're two different, this is a different color here because I got a different version of Cadence installed, but I'm still using the older version. But these are the two files you would turn in.